In 1978, a military committee ordered a basic replacement utility truck. What the engineers built instead accidentally created the four-wheel drive technology that would win the World Rally Championship. Nobody in that briefing room had any idea. We will get there. These are the 10 most overbuilt military mini 4x4s ever built. 9 countries, 5 decades. Machines built so far beyond what their size class demanded that armies refused to retire them even after their replacements arrived. One is still being manufactured today. One was retired for being too sophisticated to maintain. One weighs 590 kilograms and had portal axles on all 4 corners. Stay until number 1. The engineers who built it had no idea what they had created, and neither will you until you hear it. Number 10. DKW Munga. We open with the one almost nobody knows. Before the iconic shapes, before the famous names that appear in every military documentary, before the vehicles that fill museum collections across Europe and America, there is a small German 4x4 from 1956 that most automotive historians have never seriously examined. That obscurity is unjustified. What this machine represented in 1956 was years ahead of what most military planners understood a light 4x4 could do. The DKW Munga was developed by Auto Union in the mid-1950s as West Germany's first domestically produced military 4x4 since the Second World War. The Bundeswehr needed something reliable, simple, and capable in the Central European terrain that NATO planners had identified as the most likely operational environment for the alliance. Auto Union's engineers built something that met those requirements and then added a feature that almost no military vehicle of the same class offered as standard: permanent four-wheel drive. Not part-time, not selectable, permanent. In 1956, when competitors relied on driver judgment to engage four-wheel drive at the right moment, the Munga delivered it continuously without any intervention required. The traction advantage in changing terrain conditions was immediate and measurable. Drivers who had operated other light military 4x4s and then moved to the Munga reported the difference as significant in practical field conditions. The mechanical layout supported this capability with equal thoroughness. A 2-stroke 3-cylinder engine was selected not for its power output, but for its cold start reliability and mechanical simplicity. 2-stroke engines have fewer moving parts than 4-stroke equivalents of comparable displacement, which meant fewer failure points in field conditions where mechanical knowledge and spare parts could not be assumed. The open body construction with a completely flat floor allowed rapid reconfiguration between troop carrier, communications vehicle, and weapons platform roles without tools or specialist equipment. The entire vehicle could be stripped to its essential components and reassembled by its crew. Approximately 46,000 were built between 1956 and 1968. The Bundeswehr continued operating the Munga for 12 years after the Volkswagen Iltis, its designated replacement, was ready for service. That continuation was not a procurement failure or a budget constraint. It was a deliberate operational decision. The Munga kept working correctly in the conditions it was used in, and no justification existed for retiring something that functioned as intended. When armies refuse to stop using a vehicle after its replacement arrives, they are providing the most credible reliability certificate available. The Munga earned that certificate across more than 2 decades of continuous service. Number 9. Willys MB Jeep. Every vehicle on this list exists because of what 2 American manufacturers built between 1941 and 1945. The Willys MB and its mechanically identical twin, the Ford GPW, did not merely define the military Mini 4x4, they proved the concept was viable in conditions so extreme that military planners before the war had not seriously considered a vehicle this small capable of performing meaningful combat roles. What happened between 1941 and 1945 changed that assumption permanently. The engineering brief issued jointly to Willys and Ford in 1940 was among the most demanding in automotive history up to that point. The target vehicle had to weigh under 1,300 pounds. It had to carry a 660-pound payload. It had to incorporate four-wheel drive. It had to operate in every climate and terrain condition the United States military might encounter anywhere on Earth. And it had to be repairable by personnel with basic mechanical knowledge using tools that could be carried in the vehicle. Both manufacturers met every specification. The result was a vehicle that went to war simultaneously on every continent, crossing terrain that horses could not follow, performing logistics roles that no previous light vehicle had been assigned, surviving conditions that destroyed equipment designed for far less demanding applications. The standardization achievement that accompanied the engineering was equally significant. Willys and Ford built two identical tolerances simultaneously. Any spare part from a Ford GPW would fit a Willys MB without modification. In a global conflict where supply chains spanned entire oceans and field repairs happened far from any depot, that interchangeability was a force multiplier. A damaged Jeep could be rebuilt from the components of another regardless of manufacturer. Over 640,000 were produced across both factories. After the war, the pattern repeated across the globe. France built a version, Japan built a version, India built a version. Each was an acknowledgement of the same fundamental truth. What Willys and Ford had designed was so correct that the most rational engineering response from any country studying the problem was to keep building it. The Go Devil 4-cylinder engine at the heart of the Willys MB produced 60 horsepower from 2.2 liters of displacement. That modest output was not a limitation, it was a decision. Engineers who could have specified more power chose conservative output because longevity and repairability in the field mattered more than performance figures. The engine ran at stress levels that gave it a service life in military use that far exceeded what its displacement suggested. Captured examples were studied by every major military engineering program in the years following the war. The Willys MB did not just win the war, it established the standard against which every military Mini 4x4 on this list was measured. Number 8. GAZ-69. When the Soviet military began planning a replacement for the Willys Jeeps supplied under wartime Lend-Lease agreements, the engineers at the Gorky automobile plant did not attempt to replicate what America had built. They studied the operational terrain and climate conditions that Soviet forces would actually encounter, not the conditions that Western standardization committees assumed Soviet forces would face, and designed accordingly. The result was a vehicle built for a completely different set of extremes than any NATO equivalent, and it shows in every design decision the GAZ-69 embodies. The temperature range the GAZ-69 was required to operate. Across was the defining constraint of its entire engineering specification. Soviet military planners needed something that would cold start reliably at -50 degrees Celsius in Siberian conditions and continue operating through +45 degrees in the Central Asian republics. No single component design could satisfy both ends of that range without deliberate over-engineering of the systems most vulnerable to temperature extremes. The cold start mechanism, the lubrication system, the fuel delivery, and the electrical circuits. GAZ engineers overbuilt each system to a specification that Western engineers, designing for the narrower temperature ranges of Central European NATO operations, had no reason to match. The suspension system on the GAZ-69 was designed for terrain with no roads, rather than roads with occasional rough sections, a fundamentally different engineering brief from any NATO light vehicle of the same era. Where Western suspension designs were tuned to balance road comfort with occasional off-road use, the GAZ-69 suspension was built purely for sustained cross-country operation across ground that had never seen a paved surface. Solid axles front and rear gave it predictable, consistent articulation in conditions that caused independent suspension systems to reach their limits. River fording to 700mm depth required no preparation beyond engaging four-wheel drive, a capability built into the standard production specification, not added as a field modification. Over 600,000 were produced between 1953 and 1972 across factories in the Soviet Union and Romania, where the vehicle was manufactured under license as the AROIMS. The production numbers reflect the scale of the Soviet military logistics requirement, but they also reflect something else: confidence in the design sufficient to commit to production at a volume that only makes sense when the engineering is correct from the beginning. GAZ-69 examples remain operational today across Central Asia, parts of Africa, and Eastern Europe, running on original drivetrains that have accumulated decades of use. The Soviet Union built 600,000 of something. That alone tells you it worked. Number 7. Beijing BJ212. Stop. Before we continue counting down, we need to acknowledge something about this next vehicle that no other machine on this list can claim. Every other vehicle here was eventually discontinued. The Willys MB production ended in 1945. The German 69 ceased in 1972. The DKW Munga stopped in 1968. At some point, every vehicle on this list was retired by the military forces that depended on it. Every vehicle except this one. The Beijing BJ212 has been in continuous military production since 1966. 60 years of uninterrupted manufacture for active military service. That single fact is the most powerful overbuilt claim on this entire list. The BJ212 was developed by Beijing Automobile Works in 1965, based on the Soviet GAZ-69 platform that China had been producing under license since the late 1950s. Chinese engineers studied the GAZ-69's performance in Chinese operational terrain, the high-altitude passes of western China, the extreme cold of the northeastern provinces, the humidity and heat of the southern regions, and rebuilt the platform to address the specific failure modes those conditions created. The result entered production in 1966 under the People's Liberation Army. Designation BJ212, and has remained in production continuously since that date. The military forces that adopted the BJ212 read like a map of Cold War and post-Cold War conflict. The People's Liberation Army standardized on it as the primary light utility vehicle for decades. North Korea integrated it into military logistics. Iran deployed it across multiple operational theaters. The Democratic Republic of Congo used it in conditions that had no roads and no support infrastructure. Albania operated it through the entirety of its Cold War isolation. Each adoption decision was made independently by military planners who evaluated what was available and chose the BJ212 because it delivered what they required at a price point they could sustain. No vehicle stays in military production for 60 years because it is merely adequate. Adequacy gets replaced when something better becomes available. 60 years of continuous production means that every military force that evaluated alternatives consistently concluded that the BJ212 remained the correct choice for their specific operational requirements. Western automotive media has never seriously covered this machine. The countries that deployed it in active service across 3 continents over 6 decades understand exactly what it is capable of. Their continued procurement across conflicts and climates on 3 continents is the most honest product review any military vehicle has ever received from the terrain it was built for. Number 6. AROM 461. Behind the Iron Curtain, away from NATO standardization committees and Western military procurement processes, Romanian engineers in the early 1960s built something that the West has never properly acknowledged. The AROM 461 was developed as Romania's domestically produced military light, 4x4, a deliberate step toward greater independence from Soviet military supply chains that reflected the particular position Romania occupied within the Warsaw Pact. Romanian leader Nicolae Ceausescu pursued a foreign policy that maintained Warsaw Pact membership while developing indigenous military equipment, and the AROM 461 was one product of that program. The engineers who designed the M461 were not working with Western resources or technology access. They had Romanian manufacturing capability, Soviet engineering principles absorbed through years of licensed production, and a clear operational requirement: a vehicle that could serve Romanian army units across the country's varied terrain without dependence on foreign spare parts. What they produced incorporated portal axles as a standard production feature, following the Soviet military philosophy that ground clearance was a non-negotiable capability rather than an optional upgrade. The four-wheel drive system was mechanically straightforward and designed for complete field repair without specialist tools or diagnostic equipment. The M461 served Romanian army units through the Cold War period and was exported to military forces in the Middle East and Africa. Operational environments far removed from the Central European terrain it was originally designed for, yet environments where its fundamental engineering proved adequate to requirements its designers had not specifically anticipated. That adaptability across varied climates and terrain types is the characteristic that distinguishes genuinely overbuilt engineering from design, optimized for a specific narrow use case. The M461 was built robustly enough that it worked correctly in conditions nobody had tested it for. Today, the AROM 461 has essentially zero coverage on any major automotive or military history platform in the Western world. The combination of Iron Curtain origin, limited export visibility, and the general Western tendency to overlook Eastern European engineering contributions has left it absent from the records it deserves a place in. Portal axles in a light military 4x4 from 1964, built by a country operating under Cold War constraints, represents a more significant engineering achievement than its obscurity suggests. The terrain it crossed did not care about its political origins. It cared only about whether the engineering was correct. The M461 gave terrain the answer it demanded. Number 5. Steyr-Puch Haflinger, 590 kilograms. Write that down. 590 kilograms is the curb weight of the Steyr-Puch Haflinger, an Austrian military light 4x4 that was small enough for 4 soldiers to lift by hand, and light enough to be transported in a standard military cargo aircraft, without any specialist loading equipment. Now consider what was installed inside that 590 kilogram vehicle. Portal axles on all 4 corners, independent suspension on all 4 corners, front and rear differential locks as standard production features, a load carrying capacity approaching its own curb weight. That is not the specification list of a 590 kilogram vehicle. That is the specification list of a full-size military truck packed into a machine you could physically pick up. Steyr-Puch developed the Haflinger in the late 1950s in response to an Austrian army requirement for a light utility vehicle capable of operating in the alpine terrain that defined Austria's military geography. The mountains of the Austrian Alps presented conditions that every standard NATO light vehicle struggled with: extreme gradients, narrow tracks, surfaces that combined loose rock with sudden mud, and elevation changes that stressed both engines and drivetrains beyond the parameters they had been designed for. Steyr-Puch's engineers approached this requirement with an engineering philosophy that prioritized absolute mechanical capability at the expense of everything else. Comfort was irrelevant, speed was irrelevant. What mattered was getting to places that nothing larger could reach and returning reliably. The 643 cubic centimeter 2-cylinder air-cooled engine produced 27 horsepower. On flat ground, that figure sounds inadequate. In the alpine terrain the Haflinger was designed for, 27 horsepower, in a vehicle weighing 590 kilograms with portal axles and differential locks delivered terrain capability that vehicles with 10 times the power could not match because they could not physically fit into the spaces the Haflinger navigated. The mechanical advantage of the portal axle system gave ground clearance disproportionate to the vehicle's size. The differential locks maintained traction on surfaces where conventional vehicles lost momentum and stopped. The lightweight meant low ground pressure on soft terrain. The Haflinger floated across conditions that heavier machines sank into. Over 16,000 were built across the production run from 1959 to 1974. The Austrian army deployed them as primary light utility vehicles and exported them to Switzerland and other NATO allies, who recognized in the Haflinger a capability that nothing in their existing inventories could replicate at that weight class. At military off-road events and demonstrations today, surviving Haflingers regularly navigate terrain that embarrasses vehicles 10 times their mass. The size is not the limitation. The size is the engineering achievement. Everything else is the overbuilt hardware that makes that size relevant. Number 4. Minerva TT. Belgium looked at the Land Rover and decided to build a heavier one. That sentence contains the entire engineering philosophy of the Minerva TT, and it is worth understanding exactly what it means. In the early 1950s, the Belgian military needed to re-equip their light utility vehicle fleet as part of NATO rearmament commitments. The Land Rover Series 1 had established itself as the benchmark light military utility vehicle in Western Europe, and Belgium entered into a license agreement with Land Rover to produce it domestically through the Minerva company, which had been manufacturing vehicles since the early 20th century and had the production capability to meet military requirements. When Minerva's engineers examined the Land Rover series, one specification in detail, they made a manufacturing decision that reflected their company's background in quality engineering. The original Land Rover used aluminium body panels, a choice made by Rover partly for cost reasons related to post-war steel rationing in Britain, and partly for corrosion resistance. Minerva elected to use steel instead of aluminium, and to use heavier gauge steel than the equivalent panels in any steel-bodied Land Rover variant. The chassis reinforcement exceeded the British specification. Every structural joint was built to a tolerance that added weight but increased durability under the sustained stress of military field use. The result was a vehicle that weighed more than the original Land Rover, but was measurably more resistant to the structural damage that characterized military use in the field. The Belgian military deployed Minerva TTS in the Belgian Congo, where the combination of tropical humidity, primitive road conditions, and the physical demands of colonial military operations tested every vehicle in service. The heavier construction that Minerva had applied proved its value in conditions significantly harsher than the Central European terrain the vehicle had been specified for. A vehicle designed for one environment performing correctly in a more demanding one is the definition of overbuilt engineering. Approximately 2,500 Minerva TTs were built between 1953 and 1956. Production ended when Belgium standardized on the original Land Rover platform for cost and parts rationalization across NATO allies. The Minerva TT disappeared from service, and almost entirely from automotive memory. Surviving examples are among the rarest military light 4x4s in existence, recognized primarily by collectors who specialize in Cold War-era military vehicles. Belgium quietly built a more durable version of one of the most respected military vehicles ever produced, used it in some of the most demanding conditions it would ever face, and then let it disappear from the record without acknowledgement. The terrain it covered in the Congo knew the difference. Number 3. Austin Champ. Here is the most technically advanced vehicle on this list, and the one with the most ironic fate in military service history. The Austin Champ was developed by Austin in the early 1950s as Britain's purpose-designed replacement for the wartime Willys Jeep, with a specification that deliberately exceeded every performance and capability characteristic of the American vehicle it was replacing. Where the Willys had solid axles, front and rear, the Austin Champ used fully independent suspension on all four corners. Where the Willys used a basic side valve 4-cylinder engine, the Austin Champ used a Rolls-Royce designed 4-cylinder unit. In 1952, independent suspension on all four corners was a specification that most civilian performance cars would not achieve for another decade. The suspension design produced measurable advantages in the terrain conditions that the British Army evaluated. Articulation across uneven ground was superior to the Jeep. Stability on cambered surfaces was superior. The ride quality, while still genuinely austere by any civilian standard, was more controlled at speed across rough terrain than the solid axle Willys could achieve. The Rolls-Royce B40 engine delivered smooth, predictable power delivery that field mechanics reported as consistent and reliable under the demanding conditions of extended military use. By every technical measure that the Army's evaluation teams applied, the Austin Champ outperformed the vehicle it was designed to replace. The British Army adopted it, evaluated it in field conditions across multiple operational theaters, and then reached a conclusion that military historians have debated ever since. They retired it in favor of the Land Rover Series 1, not because the Land Rover was more capable across the terrain performance metrics that mattered operationally, but because it was cheaper and required less specialist mechanical knowledge to service in the field. The independent suspension system in the Austin Champ required maintenance procedures that exceeded the mechanical knowledge base that could be assumed of frontline personnel. The Land Rover's simpler mechanical layout could be maintained by a driver with basic tools and limited training. In a military context where vehicles might need emergency field repair, far from any workshop, that simplicity was worth more than the performance advantage the Champ's sophisticated suspension provided. Only 13,000 Austin Champs were built. The most technically advanced British military light, 4x4 of its era, was discontinued after 4 years of production. The engineering achievement it represented, independent suspension at all 4 corners in a 1952 military vehicle, was not surpassed in the British light military vehicle program for decades. The machine was correct. The context it operated in demanded something simpler. That gap between technical achievement and operational practicality is the Austin Champ's entire story, and it is a story that deserves to be told accurately. Number 2. M422 Mite. We are at number 2. The vehicle at number 1 created one of the most influential drivetrains in automotive history, from a military specification that nobody was paying attention to. Before we get there, we need to spend time with the most disproportionately overbuilt machine on this entire list, a vehicle that weighs 1,700 pounds and was equipped with hardware that full-size military trucks of the same era did not universally include. The M422 Mite was the smallest military 4x4 the United States ever put into production, and the engineers who built it refused to let the size determine the specification. The United States Marine Corps issued the development requirement for the Mite in the mid-1950s, with a brief that combined contradictory demands. The vehicle had to be light enough to be carried internally by the helicopters of the era, specifically the Sikorsky HUS-1 Seahorse, which had a payload limitation that imposed a hard ceiling on the target vehicle weight. It had to be small enough to be airdropped into landing zones with limited space, and it had to retain genuine off-road capability in the terrain conditions the Marines would encounter in the Pacific Theater and in the mountainous environments of the Korean Peninsula. American Motors Corporation's engineers met all 3 requirements simultaneously by refusing to compromise on the mechanical specification, regardless of how small the vehicle needed to be. Portal axles were specified for the Mite, technology that elevated ground clearance and reduced drivetrain stress simultaneously, and technology that was considered specialist hardware for heavy military vehicles, rather than standard equipment for light utility platforms at the time. An air-cooled V4 engine eliminated radiator failure and coolant freeze as potential failure modes in combat conditions, where water access could not be assumed, and temperature extremes were operational realities rather than edge cases. 4-wheel drive was standard. The combination of portal axles and ultralight weight gave the Mite ground clearance and terrain capability in technical off-road conditions that vehicles with dramatically greater power and size could not match because their dimensions prevented them from accessing the terrain at all. Approximately 4,000 Mites were built between 1959 and 1962. The production run ended not because the vehicle failed its operational requirements, but because helicopter technology advanced sufficiently that larger vehicles could be transported, reducing the specific requirement for something this compact. The Mite was never replaced by a more capable vehicle at its weight class. It was made unnecessary by a change in the technical context it had been created to address. That distinction matters. A vehicle that becomes redundant because the problem it solved no longer exists has not failed. It has succeeded completely. Number 1. Volkswagen Iltis. Nobody in that military briefing room knew what they were looking at. In 1975, the German Bundeswehr issued a requirement for a replacement for the DKW Munga, which, as we established at the beginning of this list, they had already been using 12 years beyond its planned retirement date. The replacement brief was straightforward by military procurement standards: a light 4x4 with better payload capacity, improved on-road handling, and modern mechanical systems that were easier to maintain than the Munga's aging 2-stroke drivetrain. The development contract went to Audi, which assigned a team of engineers to produce what was essentially a conventional military utility vehicle upgrade. What those Audi engineers built instead was anything but conventional. The four-wheel drive system developed for the Iltis used a permanent all-wheel drive architecture with a center differential that distributed torque continuously to all four wheels without requiring driver input. In 1978, when the Iltis entered production, permanent all-wheel drive in a production vehicle was not merely unusual, it was essentially unprecedented outside of specialist off-road applications. The technology required to make permanent four-wheel drive work practically in a vehicle that also needed to operate on paved roads had not been resolved in any production vehicle at that point. The Iltis resolved it. Audi engineer Jörg Benzinger drove the completed Iltis prototype and immediately recognized what the military specification had accidentally produced. The four-wheel drive system demonstrated that permanent all-wheel drive was not just viable in a production vehicle. It delivered traction and handling advantages in real driving conditions that no conventional two-wheel drive or part-time four-wheel drive system could approach. Benzinger took his findings to Audi management and proposed applying the principle to a passenger car. The proposal was approved. The result was the Audi Quattro, launched in 1980, which dominated World Rally Championship competition from 1981 and permanently changed how performance car engineers thought about drivetrain architecture. Every all-wheel drive performance car produced since 1980 traces its conceptual lineage to the technology proven in a small German military or utility vehicle that the Bundeswehr ordered as a straightforward Munga replacement. The Iltis itself went on to confirm its capability beyond any military evaluation procedure. In 1983, a near-standard Volkswagen Iltis in military specification entered the Paris-Dakar Rally, one of the most demanding long-distance off-road competitions in the world, and won it outright. Not in a modified version, not with specialist race preparation beyond basic safety equipment. In a configuration that differed minimally from the vehicle the German army was driving every day. Canada produced 2,500 units under license through Bombardier for the Canadian forces. The German military operated it across NATO deployments for a decade. But the vehicle's greatest contribution was never to military operations. It was to a performance car that millions of people have driven without ever knowing where the idea came from. 10 vehicles, 9 countries, everyone overbuilt beyond what the brief demanded, by engineers who understood that terrain is always harder than the paperwork describes. None of them failed that test. The Volkswagen Iltis at number 1 was ordered as a basic utility truck. The engineers built something that accidentally changed automotive history. The terrain never noticed the difference. It only noticed that the vehicle kept moving. If this video showed you 10 overbuilt machines no documentary has ever properly covered, subscribe to VROOR right now. Every week we find the forgotten, the overbuilt, and the underestimated. Subscribe and hit the bell. The next video is already built, and it covers machines that make this list look ordinary.